In this video, I'll be helping you with the ALEKS problem type called using the Pythagorean Theorem to find several trigonometric ratios in a right triangle. We're given our right triangle here, the lengths of one of the sides, and the length of the hypotenuse, and we're asked to find several of the trigonometric ratios. And in order to do that, I'm going to need all of the sides, and I see that I'm missing one here. I'll need to find the length of this leg, which for now I'll just call B, and that's where the Pythagorean theorem will come in, which tells us that a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. We'll need to find our b here. 5 is the a squared is 5 squared, plus our other unknown leg, b squared, equals c squared, and c is 13. Squaring the numbers gives us 25, plus b squared equals 169. To solve for b squared, we can subtract the 25 over, giving me b squared equals 144. And then finally, to solve for b, I would take the square root of both sides. B would be the square root of 144, which is 12. Technically plus or minus 12, but this is the length, so we can use the positive. I'll replace B with 12. And now we can find any of the trigonometric ratios by recalling our mnemonic SOHCAHTOA, where sine is the opposite over the hypotenuse, cosine the adjacent over the hypotenuse, and tangent the opposite over adjacent. And so now we can turn our attention to each of these values we were asked to find. The first is the tangent, which we recall is the opposite over the adjacent. And from theta, the opposite is 12, and the adjacent is 5, so the tangent of theta is 12 over 5. Next, we were asked for the secant, and secant is not one of the ones in our mnemonic here. We have sine, cosine, and tangent, but we know that the secant is 1 over the cosine, and since cosine is adjacent over hypotenuse, the reciprocal of that will be the hypotenuse over the adjacent. And so again here, from theta, the hypotenuse is 13, and the adjacent to theta is 5. So secant will be 13 fifths. And then our last trig ratio is sine, and sine is one of those that we remember. Sine is opposite over hypotenuse. From theta, the opposite is 12. And the hypotenuse is 13. So opposite over hypotenuse is 12 over 13. So we have found each of these trig ratios. I hope you found this video helpful. You can find a complete list of Timely Math Tutor videos organized by course and curriculum at timelymathtutor.com.